Hey guys, today we're going to talk about some more derivative rules. Now, let me give you a heads up, depending on what student you are. If you are a business calculus student, you can probably skip this section, but just make sure your instructor is not going to be covering trigonometry derivatives in your course. So that's up to you. Again, this is I call myself the Perfect Square, and feel free to subscribe to my channel if you like what you see here. Okay, so these are called the simple Trig rules because a little bit later I'm going to show you the chain rule, and that will deal with derivatives of trig functions where the argument here, like here you see the argument is x. Well, the argument could be some function of x like x cubed or square root of x or something like that. But for now, we're just going to look at the rules for your simple trig functions. So the first rule we're going to look at is the rule for the derivative of sine x. So the derivative of sine x is simply cosine x. And then the second rule is the derivative of cosine x. The derivative of that is just minus sine x. And the derivative of tangent x is secant squared of x. And that's just secant x quantity squared. The derivative of secant x is actually secant x times tangent x. The derivative of cosecant x is minus cosecant x times cotangent x. And then the derivative of cotangent x is actually minus cosecant squared x. So these are generally used in Calculus 1 courses, and that's where they're generally introduced. So we're going to look at some derivatives involving these simple trig functions. Now, the examples I'm giving you, I'm also going to throw in some other functions just to keep us on our toes. So let's go ahead and take a look at some of these examples. So the first example here is simply f of x is equal to 5x squared minus sine x. Now, you're going to have to take the derivative of each term. So the derivative of 5x squared, we all know, using the proper rule, would simply be 10x. So this is using the rules from earlier lectures. And then we know from this lecture that if you go back up here and take a look, the derivative of sine x is cosine x. And so that would be, so you would now put minus cosine x. So your derivative would be 10x minus cosine x. The next example here is actually involves a tangent. So I have tangent x plus x cubed. And we know from up here the derivative of tangent x is secant squared x. So we would get secant squared x right here. And then we know the derivative of x cubed is simply 3x squared. Okay, so the third one here is 3 secant x minus 2 cotangent x. And the derivative of secant x from up here is actually secant x tangent x. And so the derivative of 3 secant x would be 3 secant x tangent x. And then here the derivative of cotangent x is actually minus cosecant squared. So you would have, but since you have minus a minus, that would be a plus. And then you would have 2 times cosecant squared x. And that's all I'm going to do on these. If you want to see some more, you can just follow my videos until you get to the more complicated trig functions, where instead of finding the derivative of, say, sine of x, we'll actually find the derivative of sine of some function of x, like sine of x squared or sine of x cubed. Now, if you want to know where these derivatives come from, they actually come from the definition of the derivative. So the derivative of sine x equal cosine x can be shown using that limit of the difference quotient as h approaches 0 or delta x approaches 0. And the same thing for finding the derivative of cosine x, but I didn't really want to show you that in this example. So that's all I have for now, and we'll move on to some more complicated derivative rules in the next video, namely the product rule, and then the next video the quotient rule, and then finally the video after that will deal with the chain rule.